Okay, so here are the two qualitative ones. On the test, we're probably not going to ask qualitative ones. Everything's probably going to have numbers, okay? So just be aware of that, okay? All right, so a toy rocket is launched into the air by a spring, okay? So I'm going to go ahead and use the same things that they did here, okay? So the initial position, it looks like the spring is very compressed, okay, and the rocket is sitting on top, sort of being held there, okay? And then the middle one, I'm going to go ahead and say that the spring is now fully uncompressed, okay, and the rocket is just starting to move. So I'm going to go ahead and draw some whooshies on there, all right? And it's going to come off probably pretty fast. Like if you've ever like spring-loaded like a dart gun or something, right, like it's going to be the fastest just as it leaves that spring, okay? So then I'm going to say that my spring at this point is fully uncompressed and the rocket is just starting to move up, okay? And then it looks like in this picture, it looks like the rocket's still moving, so I'm going to give it a little bit of motion still. It's not all the way to the top, okay? So something really important, once it gets to the peak or the top of the motion, it's not moving. Okay, so that was something that we saw was kind of an issue on the quiz too. Once it gets all the way to the top, it's not going to be moving anymore. It's going to start to come back down. Okay, because if it was still moving, it wouldn't be at the top yet, right? So in order to actually be at the so-called top, it has to have stopped moving and then turn around to start falling, okay? So we're just going to use that. You could use the peak. It could say that, whatever. I'm just going to go with what this picture has, okay? All right, so I want to ask myself these questions, all right? EG, okay, is the rocket above the ground, okay? So I'm going to go ahead and just call this ground level. EG is 0 there, and since I'm sort of looking at the middle of the rocket, I am going to say that this is a little bit off the ground, okay? So I'm going to go ahead and give it a little bit of EG. Okay, so EG, a little since slightly off the ground, okay? All right, by this point, after the spring is uncompressed, it would be a touch higher, right? Because however much that spring uncompressed, but probably not that much. So maybe I'm going to give it like 1.5 here because it's just slightly above, just above the bottom. Okay, just above the bottom because it's raised up just slightly as that spring starts to launch it. Okay, and then here, right, it's a lot higher, so I'm going to give that, I don't know, maybe 4. I have to see how the numbers are going to play out, okay? High, above ground, okay, but not peak height yet, okay? All right, so kinetic energy, is it moving? Okay, so here in the beginning picture, it's not moving, all right, because we can see the guy is sort of holding it, right, with his little finger there, okay? It's not launched yet. Okay, so EK 0 since not moving, okay? Here, as this starts to launch, it's probably going to have a lot of EK, right? Because it's going to be pretty fast. So I don't know. Let me give it 3 for now. I might have to adjust this, okay? So it's going to be the fastest off the launcher, okay? Big whooshies. Do you see I have big whooshies drawn? So it's easy for your reader to tell that you mean for this to be moving fast, okay? And then as it's up here a little bit further, it's kind of slowing down as it moves to the stop or to the top. So if I took a snapshot when the rocket was up here, it would be slower, okay? Because it's going to show smaller whooshies, so less EK, okay, than there was before. So let me put, I'm going to put 1. I'm not sure how this is going to work out, okay? I'm going to have to go back and readjust the numbers, okay? But either way, my EK has to be bigger in the middle than the final because it's faster there, okay? All right, my EE, okay, now a lot of EE is stored, right? So I'm going to go ahead and let me just give it 4 EEs, all right? EE, spring, max compression, so the EE is big, okay? Here, once I said this is already uncompressed, right? That this rocket is already moving, okay? So I'm going to say that that's nothing, okay? And then here at the top, oh, I even forgot to draw the spring. I guess I should still even draw it because it's kind of irrelevant now, right? So here's the spring still here, Okay, still not compressed anymore because it's already over. So that's going to be that. So EE, 0, since no compression. Okay, and same thing here. EE, 0, since no compression. Okay, all right. Now, there could be friction from the air, which sometimes we call air resistance or air friction. Okay, but if it doesn't really say, okay, we'll try to be real clear on the test. I'm just going to not even bother with it because, you know, it's kind of a hassle. Okay, but you could put it if you wanted to, and it could have a little more each time, which would be okay. All right, so now that I did that, let me check my totals and let me see if I'm violating the law of conservation of energy. Okay, so I have 1, 2, 3, 4, 5. So I have 5 boxes here. Okay, 1, 2, 3, 4 and a half. Okay, that's not enough. All right, so let me make this a touch faster. Okay, I'm going to make this just a little bit faster. Okay, so that I now have 1 and a half, 2, 3, 4, 5 boxes. 1, 2, 3, 4, 5 boxes. Okay, good. So this looks pretty good. Okay, so I'm going to check to make sure that that's right. All right, and then if I'm going to look through my checklist, right, I'm going to see if everything makes sense. Okay, so the rocket continually gets higher. So the EG, let me see, where's that little pointer tool? Is this it? No, they changed this whole thing on me. Laser pointer, is this it? Oh yeah, okay. All right, so the rocket continually gets higher, so the EG gets bigger, okay? The rocket also changes speed, so here it's not moving, okay, no whooshies. Big whooshies, big EK, small whooshies, small EK, all right, so that's good. For elastic, lots of compression, lots of EE, okay? No compression here or here, so no EE here or here. All right, thermal, we're not going to worry about it. We're going to ignore air resistance or air friction, okay? And then I went back and readjusted and checked that every single one has 5 boxes, okay? So then I would feel pretty good about, pretty good about this one, okay? All right, let's do the other qualitative one. We'll do this one in the same video. Okay, a cyclist is moving up a steep hill, not pedaling, okay, coasting, right? Coasting means not pedaling, all right? So I'm going to start her down here, okay, and then maybe I'll make her like maybe up here somewhere, and then here she'll be maybe at the top, okay? All right, and this one tells me clearly there is friction, so I'm going to have to include the ETH, all right? Okay, so let's think about where we want the ground or ground level to be. So I'm just going to put it, you know, down here. EG equals 0. Okay. EG equals 0. All right. Okay, so then if I'm tracking her height, I mean, technically in physics, we usually go to the middle of the object, right? So I guess this could be slightly off the ground. Or you could have just said maybe like this level is the so-called ground level, and then you wouldn't put it at all, okay? So I could see it either way, but you need to be specific. So I'm just going to maybe go ahead and give her 1 here because she's a little away from this bottom, okay? And then maybe here I'll give her 3, and then maybe here I'll give her 5 because she's continually getting higher, okay? So as the height goes up, the EG goes up basically for this whole thing, okay? All right. Now, if she's coasting to a stop for the EG, how fast do you think she's going at the beginning? Fast or slow? Right? She'd have to be going fast because if she was already going slow, then she wouldn't really go anywhere, okay? So she's probably already moving pretty fast. So let me give her maybe 4. Okay, so the EK, she's fast, so the EK is high, okay? So I'm going to give her big whooshies, and I'm going to be super obvious about what I'm doing. All right, I'm going to make it very clear what my whooshies are. All right, now as she continues to go up the hill, she's probably going to be slower now. So I'm going to give her like medium whooshies. Okay, so maybe she's going to get, I don't know, 2 EKs. Oh, my thing is dead already. My pencil doesn't charge. Hold on. Okay, so she's going to get 2 EKs in the middle position. All right, as shown by not very big whooshies. Okay. And then by the top, it says that she comes to a stop, okay? So since she's coming to a stop, then we know there's going to be no EK, all right? So as soon as my pencil charges for a minute, I will hopefully have enough juice to write this, okay? So this is going to be maybe 2 because she's medium speed, and at the top, nothing, all right? Okay, and again, I might have to go back and adjust these numbers a little bit, but let's just get an idea, okay? All right, now, there's nothing elastic happening, okay, because there's no springs, there's no bungee cords, and some people are like, well, in the bike, no, too hard. It'd be super obvious. If it's a spring, a trampoline, a bungee cord, a rubber band, okay, we're looking for simplified, obvious things, okay? And since there is friction, I'm gonna have to include some ETH, all right? So maybe I'll just give it 1 bar here, and then 2 bars here, okay? Because it's gonna have to continually get that bar bigger, right? Because as she moves, right, she's wasting energy all the way to here, and then she's wasting more energy all the way to the top, okay? And that has to get bigger, all right? Okay, and none in the first picture. All right, so now let's check our totals. So in the first one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Uh-oh. 1, 2, 3, 4, 5, 6, 7. Okay, that's a problem. All right. Okay, so now we have to think about how to adjust. All right, so let's keep 7 as what we want. Okay, because that's like the ending state. I think the other ones we can adjust more easily. Okay. I don't really want to change the ETH because it goes from 1 to 2. Okay, so I don't really want to change that because that's already doing the right thing. All right. Maybe we could, let's see, we need some more here and we need some more here, okay? So maybe in the beginning, let's add another kinetic for her, okay? 1, 2, 3, 4, 5, 6, okay? So maybe we should keep 6 as our base, all right? Because I can't really change the EG, it's 1, and I'm kind of out of space for this. So I'm going to go ahead and keep 6 as what I want. 1, 2, 3, 4, 5, 6. Oh, terrific, that one works. Okay, so where can I remove one from here? Okay, I can't really remove one from the ETH because there was 1 here and 2 here and it has to get bigger, okay? I could probably lower this EG a little bit, right? Because it doesn't have to be, okay, so if I do 1, 2, 3, 4, 5, 6, that's okay. All right, because look, it still shows that she's getting higher. Okay, so maybe like this middle one should be drawn slightly higher than it was, or I could have made this one like 2.5 and this one 2.5, which might have even been a little bit better, okay? But again, it doesn't have to be perfect as long as it follows the rules, okay? So let's check our rule list, our checklist, and see if it does everything, okay? So the EG continues to grow. She continues to get higher. Good. Again, it doesn't have to be perfect as long as it follows the pattern, okay? Her speed is continually getting lower. Her whooshies go from big whooshies, medium whooshies, no whooshies. And no whooshies mean no kinetic energy, okay? So that's good. There's nothing elastic to worry about. Who cares? Okay, and her thermal, nothing in the first picture. By the time partway through, she's wasted some, 1 box of thermal energy. And then as she continues to move, she's going to continue that friction rubbing process. So that needs to get a little bit bigger. Okay, so then that goes from 1 to 2. 6, 6, 6 are my totals. So this one is good. Okay.